Bernoulli's principle. The Bernoulli's principle states the relationship between pressure, density, and height in a moving liquid. The principle states that an increase in the speed or flow in a liquid occurs with the decrease in either the pressure or the height. The principle of conservation of energy states that energy in a flowing fluid is equal at all points when there are no external forces such as density, pressure, and height. Thus the kinetic, potential, and internal energy is constant when the flow is constant. Bernoulli's theorem extends and is derived from the law of conservation of energy. In a fluid flowing horizontally, if the speed of the fluid increases, it is because the fluid on that point experiences a lower pressure. The speed decreases because it has moved from lower pressure to a region of higher pressure. Bernoulli's principle can be derived from Newton's second law of motion that states the speed changes when the external force acts on the object. In a flowing liquid, there is more pressure from behind than in the front, thus giving acceleration to the flow. Bernoulli's principle is applicable only for isentropic flows that have no heat transfers and reversible. The simplest form of Bernoulli's equation is applicable to most fluid flows and some gas flows. The complex formula is applicable to flows with high Mach number. Bernoulli's equation is a simplest form. V equals the speed of the fluid flow. G equals the acceleration due to gravity. Z equals the elevation or height. P equals static pressure. Rho equals density of the fluid. The Bernoulli formula is valid based on the following assumptions. 1. The flow must be steady and cannot change with time. 2. The flow is incompressible and the density is steady all the time. 3. The friction is almost negligible.